Good morning, everyone. Let's continue with inverse Laplace. Just see the previous video. What we had done in previous video, previous two videos rather, we found how to find inverse of algebraic function. Just in 1 minute, I will recollect everything. For algebraic, I gave you 4 steps. My first step was check whether you have direct formula, and again I have given you few sub steps how to check it as direct formula. If yes, apply. If no, my second step was check, can you replace s plus a or s minus a by s, and by replacing are you getting standard formula? If yes, use first shift theorem. If no, you have to go either for step 3 or for 4. It depends on the function, whether 3 or 4. Third one I give you use of partial fraction, and fourth one I give you completing the square. So these were the steps when you are finding inverse of algebraic function. Now today we will see how to find inverse when the function is logarithmic function, or the function may be tan inverse, function may be cot inverse. This is the special case of these three functions. Now to find this, see, I am trying to avoid use of any theorems of inverse Laplace. These are the same. What are theorems we have seen? For Laplace transformation, same are there in inverse Laplace, obviously reverse way. Like the first one, when we saw Laplace transformation, we use first shift theorem. Everyone knows the first shift theorem was this Laplace, that is f bar at s minus a. I didn't tell you first shift theorem in inverse Laplace, but we used this same. And that was the second case in algebraic. I explained you how to use it. Exactly same way now. After this, whatever statements or properties we had seen in Laplace, see, one of them you have seen L of TFT, that is multiplication by T, is minus derivative of f bar s. Now if you try to write it in the reverse, whether the L inverse of this will be TFT, etc., that is a bit tedious. So I am avoiding that. I tell you, using this statement only, we will find the inverse. We had for t, same way we had for t square, and it is t square. It is the second derivative, and the sign is plus, and it is t cube. Third derivative, sign is minus, etc. So this everyone knows, we had done it. Now I will tell you when to use, and then I will tell you how to use. So first thing you remember, whenever you want to find inverse of log, tan inverse or cot inverse, remember these three functions, especially whenever you want to find inverse of logarithmic function, tan inverse or cot inverse of anything, we use L of TFT. Now let's see how to use. Let's start with the problem. See, our problem is L inverse of log of s plus a upon s plus b. You have to find this Laplace inverse. Just see the way I am writing, some simpler way. So I will start with, let L inverse of this is f of t. Means clearly we want to find f of t. Now L inverse of this is f of t. That gives me L of ft is log of s plus a upon s plus b. Simple step. Now as I said, whenever it is log, tan inverse or cot inverse, remember these three functions I am repeating: log, tan inverse and cot inverse, then we have to use TFT. Why so? You will immediately come to know as soon as I complete this. So my point is, the moment I saw this function, I saw it is log. That means beforehand I know what I have to use is TFT. We know it is log, so it's there in our mind. We have to use TFT. So we have to use TFT, so let's use. So my next step will be log of TFT. Sorry, Laplace of TFT. So what is Laplace of TFT? It is minus d by ds of this. Now, clearly we have to take derivative, and derivative of this will be easier if I write this in splitted form. What I use is log a by b is log a minus log b, and this is now minus. What is derivative of log of s plus a, that is 1 upon s plus a minus 1 upon s plus b. So what I am getting is 1 upon s plus b minus 1 upon s plus a. This is our Laplace of TFT. Just see why we had done all these things. Now you will come to know. After doing this, once you reach to this, just observe this and think, can you find L inverse of this? Yes. Why you can find? Just see. This is algebraic. Go for the steps which I give you. First step, direct formula. Second step, first step theorem. What is applicable here? You can see there is direct formula. Direct formula of this, we can find Laplace of this. What is Laplace of? We can find inverse of this. What is inverse of 1 upon s plus b? It is e raised to minus bt. This is e raised to minus at. While writing, take care. This is not equal to this. Inverse of this is e raised to minus bt, e minus e raised to minus at. That means Laplace of this is our given function. So this is nothing but L of this. Now we got L of TFT is a log e raised to minus bt minus e raised to minus at. Obviously that gives me TFT is e raised to minus bt minus e raised to minus at, and that gives us our f of t is e raised to minus bt minus e raised to minus at upon t. You already learned Laplace. You can again cross check. Find the inverse. Find the Laplace. You know how to find Laplace. Division by t. Find Laplace of this. Find Laplace of this. Division by bt means it's integration from s to infinity. Just recollect previous videos, and when you do that, you are going to get back this. Now I keep this problem here itself, and I want to solve one more, just to tell you one point. For that, just recollect the steps. What were the steps I told you here? What we had done? My step 1 was, first thing keep in mind, once again I am telling you, when it is log, tan inverse, cot inverse, we are going to use TFT. So my step 1 is write L of the given function as ft, L inverse of whatever is asked to us is ft, and that gives us L of ft is our given function. I will take this as my first step. You can say this my step 1. My step 2 will be use L of TFT. How will I use L of TFT? Means we are going to get L of TFT, which is minus d by ds of whatever you have obtained here. And my step 3 will be whatever is this after simplification, find its inverse. This is very important. Why we will come to know in my next problem. So your next step is find its inverse and write it as, of course, L of something. Then you can equate. My next step will be equate it to TFT. Whatever inverse you have found out, obviously it will equal to TFT and you can get FT. So just rough steps I give you, and now I will have one more problem where I can tell you I have written all the steps in this way. My next problem is find L inverse of the small changes you can compare with this. It is L inverse of S into log of s plus 1 upon say s minus 1. Why I am taking this problem? Just listen now. I'll follow the same steps. Let L inverse of so and so be ft. So my next step will be L of ft is log s plus 1 upon s minus 1. So we know it is log. So we have to use tft. So this will be again s into log of s plus 1 minus s into log of s minus 1, and now we have to take the derivative. Okay, now just let's see what is the difference in this, rather why I have chosen this problem. When you take the derivative, let's find out s into log, you know it will be uv. So derivative of s is 1, log s plus 1 as it is. I think I don't have to explain the derivatives. I am just using uv minus log of s minus 1 minus s upon s minus 1. Fine. And now come to this. Why I wrote this, now you will understand. See, after using TFT, take the derivative, and my next step, whatever you got here, find its inverse. Whatever we got here, compare the previous problem, whatever we got here, you have to find its inverse. So you can equate it to TFT and you can get FT. So our next step is find inverse of this, and that is the big thing. When I want to find inverse of this, do you know how to find inverse of log? Other previous case we got direct formula. Here we don't know how to find inverse of log. But the same thing I'm telling you, I told you 2-3 times, whenever it is log and we want to find inverse, means we have to use TFT. And my next step is find inverse of this after taking the derivative. So after taking derivative, because I want to find inverse, that's the reason once again I am using TFT, which becomes T square FT. So I have L of T square FT, which will be minus of derivative of this. That minus minus will be plus, and I am going to get this. See why I am giving more importance for this step, rather why I wrote this is, understand these points. Many times if you just see the solutions, you will see directly many people start with L of t square ft. That's absolutely correct. No way it is wrong. It is perfectly right. But just from students' point of view, rather those who are beginners in learning of inverse Laplace, for them, why I changed the method, why I have given you this step is, initially, how you will understand, you have to use TFT or T square FT or T cube FT. That is the doubt many students get. And that's why I am telling you, I am not started with T square. The only thing keep in mind, whenever it is log, we have to start with T. And after starting T, FT, whatever you get after applying, my next step is get the inverse. And because I have to get the inverse, and it is in terms of log, for log I must I must use TFT to get the inverse. And that's the reason once again I am using TFT, which is T square. So again I am telling you, you may find many places the solution is obtained by directly use of T square FT. That is perfectly right. If you can understand that, you can continue with that. But you may have this kind of doubts like why to use T square, rather when to use T square, when to use T, when to use T cube, etc. For that, again I am telling you, I have given you the steps. Whenever it is log, use TFT. Whatever you get, you have to find its inverse, and to find inverse of log, you have to use TFT. After this, if you get again log, again TFT, so it becomes T cube. And this way you can understand when it is TFT, when it is T square FT, when it is T cube FT, etc. But now I think you all can complete this. What is the derivative of this? 1 upon s plus 1. Here when you take the derivative, it is u by v. So it is minus s into 1 upon s plus 1 square. This is again s minus 1 minus sign, best way, precaution, use bracket. So it is again s minus 1 minus s upon s minus 1 square, and with this we are getting 1 upon s plus 1 plus this is 1 upon s plus 1 square minus 1 upon s minus 1, again this s is gone, minus 1 is left, minus minus plus, go stepwise, and now you can see after applying TFT, whatever you get, our next step is find its inverse. So again our next step is find its inverse. Now suppose again you are getting here log, again I will go for TFT because my next step is find inverse. But here I am getting everything in algebraic. The moment you get algebraic, go for the steps I gave you. First step, direct formula. Let's do one by one. These are simple. You can get the answer immediately, but I'll just recollect the step. First step, recollect the formula. 1 upon s plus 1. See, you know the direct formula. 1 upon s plus 1 inverse is e raised to minus t. Here, we don't know the direct formula. Go for the steps. I am recollecting the step. First step, algebraic. See, do you have direct formula? If yes, apply. Here you can see the steps. Here, no direct formula. For the second step, can you replace s plus 1 by s? Yes, you can replace. Only thing now you need to write it directly. You can replace this by s. When you replace this by s, you are going to get 1 upon s square. And what is the inverse of 1 upon s square? It is t raised to 1 upon 1 factorial. But we have replaced s plus 1 by s. So outside you have to write e raised to minus t. Same way now, 1 upon s minus 1, there is direct formula. So I will write e raised to t. 1 upon s minus 1 square, no direct formula. I will replace s minus 1 by s. S minus 1 by s, so I write here e raised to t. And again 1 upon s square inverse is t. But its inverse of this is this. So again I am telling you, we have to write it L of this. And what's our next step? Equate t of t. Here I need to equate t square f t. So now I think you can complete. We got t square ft is this. So obviously our ft will be this whole upon t square, and this way you can get the inverse. And same way you can solve tan inverse problem. Same way you can solve cot inverse problem. So this was our second type. First we have seen algebraic. Today we are seeing logarithmic, tan inverse or cot inverse. So this was a major point I wanted to tell the students, those who are learning it newly, when to use t, when to use t square, how to understand. So these are the steps for that. Of course now you complete this and you can get the inverse of our required function. That's it. So I'll stop here, and next video we are going to see one very important theorem of inverse Laplace, that is convolution theorem. So again I will tell you when to use convolution theorem and how to use convolution theorem. So till then, goodbye and have a nice day.